Welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we have a special show focusing on the social network X, formerly known as Twitter. We're going to discuss what we observed during X's recent domain migration, and also examine how the social network has performed before and since Elon Musk purchased the company, and see if there are any lessons to be learned for organisations looking to evolve or expand their services. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow on Apple Podcasts, Spotify, or wherever you like to listen. On with the show, and I started by asking Mike to cast his mind back to the days before Elon Musk and how the site performed before the change in ownership.
We have to remember, first of all, we're dealing with an infrastructure that's been in place for a number of years. So if you think about when Twitter was formed, it was exactly in 2006. So they actually designed this architecture with a very specific task in mind. They were going to be doing the messages and building it out from there. They realized they were going to have a worldwide distribution or worldwide audience, so everything would be designed accordingly. So when we talk about the outages, and everything's then evolving and growing on top of it. So absolutely, there was outages that occurred on this environment there. But as the user population sort of grew, it went with it, as it were. So we started to see sort of these outages coming across. And the disruptions were really, I'm not saying limited, we actually did see disruptions occurring on the environment, such as in 2008, there was a network capacity issue during Steve Jobs' keynote they were using to sort of broadcast over Twitter there. So, this was sort of used then as an implication of it actually could fail, this architecture could fail. But obviously they learn from these issues and they start to then build the architecture up. Then again, we sort of had some outages to occur. And as that network started to grow, they're then subject to other people. So we've talked about in this podcast before about sort of the BGP route leaks, where your network is advertised somewhere else. So in 2016, they were the victim of one of those. So they experienced an international outage. So it took their entire environment down, where a particular ISP erroneously advertised its network as the best way to access Twitter. So that meant all the traffic was going through that ISP, and then you start to get the drops there. And again, we saw something else similar in early 2022, where there was a BGP hijack issue occurred as well. So again, going back to the fact this architecture is there was obviously outages occur. And again, we talk about this quite a lot in this podcast is you can't avoid an outage. Deaths and taxes, outages are the other thing that's going to occur there. So what you have to be is sort of prepared for this type of thing. So it is a fairly resilient architecture. It's a really nice distributed CDN architecture where you're actually close to the users. And I say it was designed with this specific task in mind of delivering these instant messages, being able to do that rapid communications, and then involved sort of adding video streaming sort of stuff, pictures and everything around there.
As you said, the architecture was clearly designed to cope with enormous scale. But what particular challenges do social networks face when it comes to designing a robust architecture?
So the first thing you have to remember when we're talking about this is we need a solid architecture. That architecture has to encompass essentially the globe, because we're talking about these large networks at that scale, then we have to be able to distribute. And part of this is to be able to get the performance for my end users. My users are going to be distributed. So this is where I'm looking at sort of a CDN architecture. Then I've got to have things like the redundancy within that CDN architecture. And then you've got to think about how I get there. So my name resolution and all these types of stuff has to be taken into consideration. And I have to be able to do that on a global scale. I really can't have any single point of failures or avoid a single points of failures. Now, if I want to increase that functionality that my application has in there, let's take it back to whole application. I have to then consider, does my underlying architecture match what it is I'm trying to achieve? Because what you want to avoid is sort of bolting bits on. So creating a Frankenstein's monster, as it were, adding spare parts onto here to try and make it work. What you start to do in that is you incur technical debt. And what I mean by technical debt is that there's things that at some point I'm going to have to go back and change, because at some point they're going to become debilitating to the overall function of the application. It's going to make it slow, or it's going to prevent me actually moving on. And when you get to that point, what you then have to do is you have to sort of rip the whole thing down. Now, if we're considering that we're in this world, we're dealing, or every application these days, if you think about the global economy, we're dealing with a 24/7. Everything's got to be up, it's got to be there. If I pick up a phone, I expect there to be a dial tone. It's no good if there's no dial tone. And this is the same. I'm going to look for the results from the soccer game. I need to be able to understand what's happening sort of there and there. I want that type of thing. So what I'm saying by that is if I have to take my system down to re-architect everything again, then I'm going to have these problems. It's going to be out of operation for a period of time. And this is going to impact my user loyalty.
So when a company changes ownership, how important is stability to maintaining the performance of that network?
Leading into any merger and acquisition, what you really want is that following that completion, you expect to see relative stability of the IT network and operations. So this is for a number of reasons. One, it's sort of due diligence where you actually want to go in and understand what's happening. But you have to think about my customer base. Part of the reason for where I've actually gone into this merger and acquisition is obviously to grow the footprint of an organization, but it's because of that customer base that comes with it. So what the last thing I want to do is to sort of start alienating those. So I don't want to move them off. They're expecting a certain level of stability that they've had prior to that and the performance that they want to get out from there. Whilst we're going through this due diligence to understand what's on that system, to see what's happening, we need to really understand sort of what's happening across that environment. And then I can start to make my changes across there. Now, in the case of Twitter, of X, we're dealing with a massive user base. But any merger and acquisition is going to face these same issues, which is to retain that customer base, to show them that the experience that they have is going to be maintained, hopefully not just maintained, enhanced, and that will keep them loyal to us. So the loyalty is one aspect to it, but it's also maintaining that brand reputation. But this goes across sort of all mergers and acquisitions. If you think about when a financial institution takes over, there's obviously trepidation going in there. And what I want to do is to produce these services. So I have to maintain that service reliability and the performance I'm getting out from there. I want exactly what I've had today. We're dealing with 24/7 world. I need to maintain that performance. I've quoted financial institutions there, but another base example, if you think about it from a telco perspective, as they face this on a sort of daily basis, certainly now with sort of no lock-in contracts, this issue of churn, and they're constantly trying to evolve their services and deliver these services in a more enhanced way, as it were. This goes for any merger acquisition. So you're going to grow your base. I want to keep my existing customers, but also they want to make attractive new ones to avoid that churn.
Elon Musk completed his Twitter purchase in October 2022 and instantly set about making changes to both the company's staff and Twitter's feature set. What changes have you seen since then, Mike?
It's fair to say there's sort of more frequent outages post the acquisition. So we've started to see the number and the frequency of outages occurring, but they haven't necessarily been totally user impacting. What I mean by that is we're not necessarily looking at global ones. They've been looking like they've been impacting back-end issues. So we saw sort of errors, slow performance. So these are things where I might have had an unresponsive service, or the next query, it's actually gone and actually pulled the information back. Now, we have seen situations where these unresponsive services have affected functionality. So we've seen some issues with sort of two-factor authentication. We've seen some issues where you couldn't pull stuff from the back-end system there. But they've also sort of been short duration.
So we've seen an increase in the frequency of outages since Twitter's ownership change in October 2022. Can you tell us a little bit more about that?
It looks like we're sort of going through this process initially where we're starting to do that due diligence on the system, understanding what's occurring underneath there, seeing how the systems all interact from there. Now, obviously, there have been a number of documentation there, and there was a sort of number of new staff came in. So it's actually quite a good process to go through, and everyone will do this. Now, the other thing that occurs in that is anyone who's been through this process is that if we have a different developer looking at it, there might not be anything wrong with the underlying code, but everybody thinks they have a different way of doing things. Some of that might be more efficient to them. It's just the way they actually work. We also started to see some of these situations where things were clearly being changed in the back end. So, for example, where we sort of saw a redirect. When you make a query to a service, we sort of see it redirected. We sometimes saw these loops where the redirect was pointing back to the same server that was asking it to redirect. Now, what happens then was it actually goes down into a staggered loop, basically, or goes into an infinite loop, and eventually the request times out. But then the next query that went through would actually get through from there. But I said these were not consistent, or what I mean by not consistent is that they were short duration outages that we sort of saw occurring across the period.
As we've seen in the past with other disruptions, ongoing maintenance can sometimes cause outages. Do you think that's possible in this case?
Yeah, absolutely. There's some of these were some maintenance, some of these were tweaks. And I said some of these looked like they were sort of making steps to make changes in the back-end system where we're doing. So like I say, maintenance is probably the best way to describe that.
There have been a few major outages since the Musk purchase. Can you briefly run us through these and tell us if there's any pattern to them?
Yeah, when we're talking about these as major outages, I said we had these outages occurring all the time. Then we saw these ones, when we call it a major outage, it had overall functional performance issue affecting the entire global base. So all my Twitter users would have experienced this. So, for example, on March the 1st, 2023, they experienced an instance where the timelines appeared empty with just a welcome to Twitter message. So it was as if you were logging onto the system, but the timeline didn't respond, so it couldn't call anything from the back end. What's occurring there is we're actually getting to that front door. And again, we've talked about this type of outage many times. I can get to the front door, but I can't make a call to the back end. So again, we don't know definitively what's happening in the back end there. But if a change to that system would have actually just done a blank timeline, and we saw those, but the fact then we saw this welcome to Twitter message is sort of implicit that we're actually sort of moving to sort of change something in the back end there as well. So a sort of major maintenance that was occurring. The impact of this, like I said, sort of lasted several hours. It affected the morning users in the US. So although it was a back-end system issue and it was a global issue, the impact was sort of felt in different parts of the world. Here in Australia, we're asleep at that moment in time, so it wasn't sort of widely reported as opposed to occurring during the day. 5 days later, there was another internal system change, again, which sort of impacted the functionality of the system. Twitter came out and actually said there we made some changes to the back-end system. It was an internal system change. We've rolled back the change. And again, this sort of caused disruption going on there. Now, the most recent disruption we had was in sort of late April 2024. And again, this manifests itself as application timeouts. Again, we're looking at the back-end system. So when we're trying to make a call to it, we couldn't actually do there. Now, these are ones where I'm actually not impacting the application performance, as it were, as much as I can get to that front door. I can, in a lot of cases, log on to the system, but I actually then couldn't actually make a call to the back end. And the reason I mention that is if we talk about this anatomy of the outage we do and combine these signals together, understanding what that's happening gives me a good indication of where that performance problem lies. So I said, so we could actually get to the system. It was actually timing out before we could actually do anything. Whereas if it was the authentication, and we go through various levels of authentication when we're interacting with the systems, would have actually seen that at a different stage and it manifested itself differently. To the point where they're actually making some sort of changes in the back end, and we'd actually see a redirect occurring. And then what happens then is we get pushed to an error screen that comes up. So all these different signals that sort of put together give us an indication of what's happening. And if we can put those together, we say, oh, yeah, this is in the back end. This is in this point there.
The company has now completed its move to the X domain from its previous Twitter domain. Did any issues occur around that time?
When we talk about the domain change occurring there, we're going from twitter.com to x.com. So even though the name was changed to X, what you actually would have seen underneath the covers, if you looked at the waterfall and looked at the various calls going on, you'll see them going to twitter.com. So this was this change to x.com. And that meant sort of changes. So we come back to this technical debt. It meant changes to the underlying architecture. You could have quite easily just carried on as they were doing, just do a redirect into x.com and does a redirect into there. But because they wanted to sort of do these changes and get things ready, then we're doing this underlying thing. And quite honestly, it went really smoothly. Now, a couple of things to note here. So the actual autonomous system name, so 13414 belongs to Twitter, is still Twitter. Now, they can go through and make a change to that. They can make an application and sort of make that change from there, but they've left it as Twitter. What they've changed is the underlying, say, within the code itself, where it's applicable. So, obviously the main domain is x.com, and that's how they advertise from there. So you don't go through these redirects. But then they've underneath the covers, if you actually look at how some of the calls are made, where we're coming in there, they're going to specifically to that domain, to x.com, again, which sort of believes that we're readying for something, we're building out this architecture to move forward there. So now, when that change occurred, it is relatively, if you do all the groundwork underneath, it's relatively simple. I mean, don't forget, we're dealing with a huge user base here. So there were issues reported. And at ThousandEyes, we actually observed sort of issues occurring. And when I say we sort of saw it there, we saw the change occurring when they basically flicked the switch on it and started re-advertising themselves as x.com. And we saw sort of 500 errors. So we saw sort of 502s, 503s during this migration period. If I actually start to look into what these errors were, they were sporadic and I sort of saw them. And then if I look at that pattern, we have this castellation effect. I saw those numbers go up and go down. Now, if I sort of draw a conclusion from that, these errors may have actually been caused by sort of the DNS settings being moved to point to this new name server. What then would have occurred during that is some old files within the indexing there would have sort of remained, and my first call goes to that. I can't make a contact to that. So therefore, I'm generate this service unavailable or 503. But almost certainly the next request that goes through would have actually got through. So again, we've got all these users, we've got all these tests occurring. So this is where we saw these 500s there. If I actually look at the chatter that was going on at that time, yes, there were reports of performance issues, but overall, the impact appeared to be quite minimal.
Has X's experience provided any learnings for tech companies seeking to expand or enhance their service offerings?
The base thing I can say is sort of have that end goal in mind. This was quite a good experience, or appeared to be quite a good experience in terms of, yes, we saw these sort of glitches occurring throughout the system. But if we actually take the sort of number of major outages, getting to that point has been relatively painless there. So they were able to assess the architecture and decide what it is they want to achieve from there. And again, the biggest one I can actually say is that if you do that assessment and understand the architecture, understand your end goal, then you can limit that technical debt as much as you can. You don't want to get that situation where you are creating that Frankenstein monster and then having to go back and turn the lights off and re-architect everything again.
Before we wrap up, we're going to take a quick look at the global outage numbers. What have we seen in the numbers over the past few weeks, Mike?
The global outages initially increased by sort of 38%. So that was from June 17 to 23. But then they decreased by 18% the following week by 30%. So that was in that July 1st to 7th period there. If we look at the United States, they experienced a similar pattern with a 38% increase, followed by a decrease of 29%, and then into the other week, 21%. So only 34% of the network outages in the United States centric. So that's from June 17th to 30th. And that's down from 40% in the previous 2-week period. Now, if we look at here, so in this period, we've actually come across to the end of June. So month over month, there were 890 global outages. And this is an 8% increase from what we saw in May.
We saw an increase between May and June. Is this typical, especially as we're moving into the Northern Hemisphere's summer holiday periods?
It's actually a really good point. And if we go back year over year, and I have done this, we actually can see as we come into this period, we start to see a decrease from May to June, going through the Northern Hemisphere summer and that holiday period. And then it starts to rise as we come out from that. That's what we talk about, these seasonal patterns there. This year, we've seen this rise coming into June, but it is actually attributed to a single week. And if we go and actually look at those and look at what the context of those outages, there were a whole series of maintenance outages that occurred. And we thought that it's because of the time of day they occurred, the systems in which they occur on, and again, sort of they're able to sort of track the impact that would possibly have on those end users there, is how we can then say these were sort of maintenance. And again, some of them were announced. So we're going to destructive maintenance is actually announced there. If I take those outliers out, then we're actually sort of dipping down. So the numbers come down, which is exactly what we expect to see.
That's all for this episode of The Internet Report. Please do give us a follow on Apple Podcasts, Spotify, or wherever you like to listen. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on X at @ThousandEyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.